this session. In this session, we will solve problems using superposition theorem. We will find network parameters using superposition theorem. Let us consider this problem. So in this problem, find the current I naught using superposition theorem. So this current I naught I need to find using the superposition theorem. So first we will consider when 6 volt voltage source acting alone. So what happens to the network? So what we need to do, when one source is acting alone, we need to make other sources are as 0. So when acting one source, this current source to be made as open circuit. So the network becomes like this: 12 kilo ohm, 12 kilo ohm, 12 kilo ohm, 12 kilo ohms. And this current, when only one source is acting, I will consider as I naught dash. Now I need to find what is the current flowing here, I naught dash. So how to find this current I naught dash? Now this is connected, this 12 volt, 12 kilo ohm and this one, right? So this is the open circuit. So this comes as this 12 ohm. So if I rewrite this, 6 volt plus minus, from this 1 goes to 12 kilo ohm. So this 12 kilo ohm, from this point two sources. One is 12 kilo ohm reaching to this source voltage, correct? This point is connecting to this negative potential, and the other one goes to 12 kilo ohm and this 12 kilo ohm. So this goes to 12 kilo ohm, and then through the another 12 kilo ohm it is reaching the negative. So this is 12 kilo ohm, 12 kilo ohm, 12 kilo ohm. So the current flowing from this point to this is I naught dash. So this is I naught dash. Now what is this effective resistance? 12 kilo ohm and 12 plus 12 kilo ohms are in parallel. So R1 I will consider as 12 into 24 divided by 12 plus 24, because these two are in series. So 12 plus 12, 24 and 12 in parallel. So 12 ones are 12 threes are, so it comes as 8 kilo ohm. It comes as 8 kilo ohms. So what is the current supplied from this source? So current supplied from the source I equal to supply voltage divided by 12 plus 8 kilo ohms. So it comes as 0.3 milliamps. 6 by 20 is 0.3, 1 by kilo is goes to numerator milliamps. So but this I naught dash and this source current I, what is the direction? Reverse direction. So I naught dash is equal to minus I equal to minus 0.3 milliamps. So I naught dash is equal to minus 0.3 milliamps. Now next, when 4 milliamps current source acting alone, what happens to the network? The network becomes this 12 kilo ohms, this current source, this 12 kilo ohms, this is the short, and this 12 kilo ohms. This I will consider as I naught double dash. This is 4 milliamps. Now see, this source current, this is the starting point and this is the ending point. So in this path, so if I redraw this, in terms of source, okay, this current splits into two branches. One is through this, coming back to this. So that means this is the 12 kilo ohm, one 12 kilo ohm, and this 12 kilo ohm, and then parallel with these two, correct? So it becomes 12 kilo ohm, 12 kilo ohm, 12 kilo ohm. So what is the direction of this I naught dash is? This one. Means ending of this. This is I naught double dash. So I am just rewriting this network in an easy manner. Now I can analyze this current splits into two branches. Okay, I need to find this current as I1. Then once again using a branch current formula, I can find out I naught double dash. So first to find out I naught, what is this effective resistance? So this I will consider as, this resistance I will consider as R1 equal to 12 plus 12 into 12 divided by 12 plus 12, which comes as 18 kilo ohm. Now I1 is due current flowing through 18 kilo ohm, which is connected parallel to 12 kilo ohm. So according to the branch current formula, I1 equal to 4 milliamps into resistance of the other branch 12 kilo ohm divided by 12 plus 18 kilo ohms. So kilo gets cancelled. What happens is 12 by 30. 12 by 30 into 4. 12 into 4 is 48. So it comes as 1.6 milliamps. It comes as 1.6 milliamps. This is I1. this current. Now once again this current splits into two branches. So I naught double dash equal to 1.6 into resistance of the other branch 12 divided by 12 plus 12. Both the units are same, kilo ohm, so gets cancels each other. 1.6 milliamps. So this is 0.8 milliamps. So I naught dash is minus 0.3 milliamps. I naught double dash is 0.8 milliamps. So what happens to the answer? I naught equal to I naught dash plus I naught double dash, which is equal to minus 0.3 milliamps plus 0.8 milliamps, which is equal to 0.5 milliamps. So like this, we need to find the current I naught using a superposition theorem. Let us say one more. Here also find current I naught using superposition theorem. Now only difference is in this three independent sources are there. Okay. So three independent sources. What happens when one source is acting alone? Other two we need to make a 0. So when 6 volt acting alone. So when 6 volt acting alone, this is the current source becomes open. This is the voltage source becomes short. So if I redraw this, so this is the 6 volt plus minus. Plus is connected to two branches, right? One is to 2 kilo ohms and then 2 kilo ohms comes to negative. So it comes to 2 kilo ohms, 2 kilo ohms comes to negative on this point. Okay. What is the other one? 2 kilo ohms and this 2 kilo ohms in series. So another branch is such a way that 2 kilo ohm in series. 2 kilo ohms, 2 kilo ohms, 2 kilo ohms, 2 kilo ohms, 6 volt. Now, what if this is given? I naught is current coming to this point. That means this is I naught dash. So whenever the source is connected across a passive elements, voltage drop across the passive elements remains the same. Correct? Voltage drop across the passive elements, if I trace the path from lower potential to upper potential, then it is the same potential. So what happens to this? See, if we trace the path from lower potential to upper potential, what is the voltage? Minus 4 kilo I naught dash equal to 6. Because this path, current direction and path direction is same. So according to the current and path direction, minus 4k I naught dash, based on this path, it is 6 volt. So I naught dash equal to 6 by minus 4k. That means minus 1.5 milliamps. Minus 1.5 milliamps. So I naught dash is minus 1.5 milliamps. So next, when 12 volt source acting alone, When 12 volt source is acting alone, what happens to this? So I'll redraw. $12 volt plus minus 12 volts. See, this is the open circuit and this is the short circuit. So what happens to this? This 2 kilo ohm and 2 kilo ohm are connected in series, correct? Then these two short terminal, this is connected across the short terminal, so no use. So whenever the short terminal is connected to across the resistive element, this can be neglected. So it becomes only this much, 2 kilo, 2 kilo. See here, when this is the shorted, these 2 points are same, means zero resistance in this branch, and connected across parallel 4 kilo ohm. So this is no use because the current will flow through the lowest resistance path. So here is the shorted, so this can be neglected. So when 12 volt source is connected, only this is the network. Now, what is the current direction? It is this current direction only. This is I naught double dash. I am tracing, see, from positive current flows and this the same. So from positive to negative. So now what happens? I naught double dash is equal to 12 I naught double dash. So source current itself is acts as a I naught double dash. So it is equal to 12 by 4 kilo ohm. So which is equal to 3 milliamps. So though it looks like a complicated, I made it very simple because after shorting this resistance becomes 0. Effect of this resistance is 0. So I naught double dash is 3 milliamps. Now, when 2 milliamps current source acting alone, so what happens to the network? So 2 milliamps current source. See, from this point it splits into 2 branches. So this is shorted, also this is also shorted. So means both these resistances are connected to the same point. Then it is traveling through once again parallel branches. So it becomes this is the point, and then so 2 kilo, 2 kilo, 2 kilo, 2 kilo. So where is this point? This current. So this is one of this. So this current is, I will take it as I naught triple dash. So see, here 2 milliamps splits into 2 branches, then becomes once again 2 milliamps and split into this. So I am not interested in this elements. I want to find out I naught triple dash. So I naught triple dash is branch current formula, splits into 2 branches. So 2 milliamps into resistance of the other branch 2 kilo divided by 2 plus 2 kilo, which is equal to 1 milliamps. So when only 6 volt source is acting alone, minus 1.5. When 12 volt source is acting alone, 3 milliamps. When 2 milliamps current source acting alone, 1 milliamps. So what is the total current I naught is equal to? According to the superposition theorem, I naught dash, I naught double dash plus I naught triple dash. That means minus 1.5 plus 3 plus 1 milliamps. All the units are same, so milliamps. So it is 2.5 milliamps. Okay, right. Now find the current I using superposition theorem. Now compared to previous two problems, there is one dependent source. So whether we need to consider this dependent source as a source? No. Because by the definition of the superposition theorem, when there are multiple independent sources, not a dependent, so we need to retain this as a dependent source only. So what happens when 24 volt source acting alone? So when 24 volt source acting alone, this is the 24 volt source, this is 3 ohms, 2 ohms, this acts become open circuit. So 3 ohms, 2 ohms plus minus 3I. So this is plus minus 24 volt, and this current I will consider as a I dash. So when this is I, this is 3I. Now in the network, given this current I, this is 3I, depends on this current. So here this I becomes I dash, so this is 3I dash. Whatever the current flowing through 3 ohm is the dependent parameter. So this is 3I. Now apply KVL to this loop. Apply KVL to this loop. So what I will get? 24 lower potential to upper potential minus 3I dash minus 2I dash, 2 into current, voltage drop. This is the higher potential to lower potential. So minus 3I dash equal to 0. Just I applied KVL. So path direction and current directions are same. So minus 3I dash and minus 2I dash. This is in the path direction voltage falls, plus to minus voltage drops. So minus 3I dash. So total what happens? 8I dash equal to 24. So I dash equal to 3 amps. I dash equal to 3 amps. So when only 24 volt source is acting alone, I dash is 3 amps. So now let us see what happens when 7 amps source acting alone. So what happens is 3 ohm. This 24 volt becomes a short. Now this I will take as I double dash 3 ohm, and this is 2 ohm plus minus 3I double dash. Now how to find the current? So this is given as 7 amps. So I will consider this as V1. So I will apply node voltage concept, because I cannot apply branch current formula, because though this is the 3 ohm, this is the branch where dependent voltage source is present. So I cannot apply branch current formula. So according to this, what happens? This one, 7 amps is incoming current. So plus 7 minus this current, I will take it as V1 by 3, this is the reference, V1 minus 0 by 3, V1 by 3 minus, what happens to this? This is 0, so this is 3I double dash. So V1 minus 3I double dash divided by 2 equal to 0. Correct? V1 minus potential at this point is 3I double dash divided by 2. So what is I double dash? I double dash is current flowing in this direction. That means 0 minus V1 by 3. So V double dash is minus V1 by 3. Correct? This is the V1 by 3 is the current in this direction. So opposite means minus V1 by 3 is I double dash. So substituting this in this equation. So what will happen? 7 minus V1 by 3 minus V1 minus V1 by 3 whole divided by 2 equal to 0. So what will happen? 7 minus V1 by 3, 7 minus V1 by 3, what happens to this? V1 plus V1 by 3, so 4 V1 by 3, so it is minus 4 V1 by 6 equal to 0. So what happens to this if I take LCM common? V1 by 3 minus 4 V1 by 3. So this is V1 equal to 7 volt. When V1 is equal to 7 volt, what happens to I double dash? So V1 equal to 7 volt. So if I take a LCM, what will happen? 6, 2V1, 2 plus 6, yeah. V1 equal to 7 volt. So what happens to I double dash? Minus V1 by 3. So minus 7 by 3 amps. V1 is equal to minus 7 by 3 amps. That is I double dash. So I dash is 3, I double dash is minus 7 by 3. So what happens? The current I is equal to I dash plus I double dash, that is 3 minus 7 by 3. By taking a LCM, 9 minus 7 is 2 by 3 amps. I by 3 is 2 by 7 amps. So this is I double dash is only 7 amps current source is acting alone. Okay. So this is, let us more problem. Find a voltage VAB using superposition theorem. So in this I need to find VAB. Here also dependent source is there. So first, when 4 volts source acting alone, so what happens to the network? dependent source remains as it is. So plus minus, I'll take this as VAB dash. So what happens, this voltage source, when it is AB, 3 VAB. So this is 3 VAB dash. So this is 10 ohms and this is plus minus 4 volt. Now this current source acts as an open circuit. Correct? So what now apply KVL to this. What happens, this current through this 10 ohm, it is connected to open source, open circuit. So current is 0. So what happens, this apply KVL. So 4, this is voltage drop is 0, plus to minus, minus 3 VAB dash minus VAB dash equal to 0 by applying KVL to this loop. So lower potential to upper potential plus, this is the, as it is, this 10 ohm is connected to open circuit, so no current flows. So current I equal to 0. So voltage drop becomes 0. So plus to minus, voltage falls, minus 3 VAB dash. This also plus to minus. So VAB dash equal to 1 volt. When 4 volt source is acting alone, VAB dash equal to 1 volt. Now next, when 2 amp source acting alone, when 2 amp source acting alone, what happens to the circuit? So this becomes a short. This is 10 ohm plus minus plus minus VAB double dash. So this becomes 3 VAB double dash. This is 10 ohms. Now, how to find VAB? Now this 2 amps is flowing through this. So the current through this 10 ohm is in this direction 2 amps. Because other end is connected to open circuit. Now trace the path from lower potential to upper potential. So what happens? VAB double dash, this voltage VAB double dash equal to tracing any other path. So equal to, if I trace from lower potential to upper potential, in the path direction current is opposite. So 10 into 2, 10 into 2, what happens to this? Plus to minus, voltage falls, so minus 3 VAB double dash. So these two equations are same, because VAB double dash, by tracing a path from lower potential to upper potential, this is the directly VAB dash, and this is by tracing another path. So what happens, this 4 VAB AB double dash equal to 20. So VAB double dash equal to 5 volt. So what happens to VAB? VAB dash plus VAB double dash equal to 1 plus 5 equal to 6 volt. So irrespective of whether it is the voltage parameter need to be calculated or the current parameter need to be calculated, concept is the same. Calculate the parameter using one of the source at a time by making other sources to 0. And then at the end add all the responses. This is what superposition theorem says about. So we will conclude this session. Thank you.